Hello, everyone, and welcome to October Patreon. Today we will build something like this. So this is like a sculpture. We will go over the building process, and we can do some rendering and lighting in Octane for this tutorial. I think the next one will be Redshift, but we will see. I think the basic principles of course apply to every render engine. But yeah, we will build something like that. I think it looks pretty cool. You can also then later animate it. So those are like expanding soft bodies from Vellum. So those are the little star frames. And let me check. Okay, working everything. Perfect. I will give you like a quick rundown. Let's just delete that. Cameras, light. Okay. Yes, this rundown first. So I experimented with like a lot of few things. So they will be in next month's tutorial. Also new NPM stuff, etc. I think will be pretty nice. But this is our tree here. So I will give you a quick rundown now. We'll start with a sphere. VDB that, convert that basically to this little sculpture here, which is pretty cool. Then we will place manually. Of course, you can also develop a procedural method, but I like, yeah, just some things to be like analog. To get like the ductus or like an analog input, I think it's sometimes pretty cool. Then we will create a pressure mask to like blow the things up a little bit. And then we will, let's wait a second. You can already see it here. We will, yeah, just basically expand them. The little vellum balloons here. And after that, so that's pretty high. So we got a pretty high pressure going on inside of here. So we got, I don't know, what's that? Yeah, 35. So we will get a quick expanding. Of course, you could also animate that. Then I cached it out basically. So this is like the blowing, and you can see it's also like animated. And currently it's not viewing on the right collision geo. Better. So you can see it's like animated. So that's already in there. And I think that's kind of cool because I think it's like, it's pretty subtle in a way. And it's somehow, I think, especially down here with the collision a little bit. I think it's like breathing, slow breathing. And I think that's pretty cool. Then I will just search for shift, for time shift that I like. Pick out a frame. I will subdivide that. And yeah, there was the infamous viewport bug. And then I played a little bit with random mask. So here's, for example, a bounding box mask on top of my, where's it? Bounding box here. So this is just like a little mask to create shaders with. This was nonsense. And then, yeah, the inside, so we will merge those two together. And then we will create a simple convex hull. What we will do, we will scatter some points on there, make like a velocity field, play with hair generation, and we will advect them with the velocity from curves, so you will get really nice hair. And then we'll use that to collide VDB and generate hair from those. So you can see that here. Wait, just go here. That would be tightness attribute, and you can see, let's just get it something we can see well. Inferno maybe? Yeah, that sounds good. And you can see we'll create those hair chunks or hair clusters, which I think really like elevates our whole sculpture in the end. Let's get that back to white to red. That's fine. We will merge that all together and we will render it out, and we will split the hair to also render the hair. Okay. I think now it's a good term to like get started here on our first little node tree. Okay, let's start with a sphere. You can choose basically whatever form you like. That's fully up to you. You can use a displaced sphere, you can use a box, etc, etc. So that is fully up to you, so play around with that. I used a mountain here to just create like a little bit of displacement. Of course you can also use a VOP, but let's just also use the mountain node, because I think the mountain node, if you need something like quickly, I think it's pretty cool. And for this one, let's just do it more elevated. I want to get it like a little bit more elevated, or what would I like to do? Let's just do it like that. Let's just make it a little bit manual. I will make it smaller, so I will make it a little bit smaller in the depth and in the width. And what I then can do, let's just create a point warp here and make a manual setup with the noise. I want to create a bounding box center. So relative to bounding box, connect that to here. So this is the file, this is our input 0 basically, our self geometry and our precision. And what I want to do is to make that a little bit taller, 1.25. Let's get a little bit more frequency here. And what I want to do, I want to ramp the Y axis, so the Y bounding box, and we'll do that with vector to float. So vector to float. Grab that, place that, and this is X, Y, Z, and we need the Y component. So grab the second component, and we will remap that as a ramp. And let's call that ramp underscore displace. And then we need a displace along normal. We need an anti-alias noise. We need a multiply and a parameter. Type the parameter in here, that one in here. This will be our multiply. This will be our adjustment. This into amount here, and this scale. And now you basically see nothing. First of all, let's just visualize the noise here, because I want a little bit to see how the noise will look like. Okay, I think 1 is fine, and what I want to do is make it a little bit less rough and just pump it up a little bit. And then what I want to do, dive up a level. And now we can basically remap our little elongated sphere to, for example, let's go for smooth. What I want to do is to get it like smooth on the bottom. And then I want to really extrude it. And what we need to do, we need to fit our noise here, because it's currently from -0.5 to 0.5, and I want it from 0.1 1, 5 to 1. And then we will get something like this. Looks like an abstract nail. And then the cool thing is we can always like come back and remap it if we want to. We could make it like really kind of non-bulgy. I think it's okay. Let's keep it like that, and I want here a little bit more. So 0.25. Okay, cool. Then what I want to do is to get maybe like a little bit more detail on the bottom and a little bit more here. So it's not like that looks cool. And then what we can do, get rid of the 0 offset. And I think that looks fine. Okay. Then what we need to do, convert it to a density volume. So VDB from polygons. 0. I don't know, 0.25. And then density, and I think 0.001 would work nicer. And then we place just the VOP. So volume VOP. And I think I used the curl noise here. Yeah, negated curl noise. Curl noise. That. Position. And then negate it. You don't need to negate it, but I like to. And then the roughness, let's play with the roughness. Frequency, the frequency of course. I will make it a little bit higher, but not too high. And then just convert that to polygons. Polygons. And we will get something like this. Cool. Now we can use like a smoothing reshape process. So what we will do is VDB from polygons again. Then after that a VDB reshape. Then we by connectivity. And then a blast node, and then a smooth node. And after that a convert VDB. Okay, so we got our little nodes placed here. So let's make this higher. A little bit more resolution. We will just dilate it. I want to just dilate it like a little bit. Then connectivity, segment by connectivity. I don't know why Houdini will not display the color. I think it's a bug. I think there are like a few viewport bugs in the newest Houdini version 20.5. I don't know why. There's, for example, quick side thing. If you place like a resample, like a vellum configure hair, and you visualize the thickness, those are now white. In 19.5 they were blue. It was way better. I don't know, maybe you can change that. I did not find a solution. Or if you like pin the points and you get like a visualizer for like the point pinned. So if I want to pin, for example, this point and this point, those will also appear as white visualizers. Why? If you got a bunch of hair, that's, I think for me, it's not good to read, but yeah, let's see. Maybe there will be an update, I don't know. Okay, then for our, our segment, so we will blast everything away except 0 surface, then smooth that and convert it. And yeah, here's the color now, perfect, I don't need it. Little rant here. Let's just smooth it even further. And I think what we can do to make it a little bit more smooth, we could like erode it, which would be pretty cool. But I think let's go for 4. And then let's move it really nicely down here. And like 250. Ah, that's too much. Let's go for 25. Oh, here's another disconnected one. Okay, I see. Let's just go for. We could go for E road. I think that would be also pretty cool. Yeah. Let's go for E road. So it's like a little bit more skeleton, and I like that. Okay, let's place all null here. And this will be our main piece. And our collider, etc. So this is our main piece here. Just get a little bit organized. Cool. Then I will start with the vellum stuff first. I think that would be like the best thing to do. Let's just go up a level, and then we will place our little spheres. Let's just do that, and then we will go for a pressure mask, etc. Cool. Let's go for some spheres. Let's move that to the side a little bit. And what I want to do is to just place like one sphere. You can use auto UV. You don't need to do it. You can also triplanar shade it, of course, fully up to you. But yeah, we will use a sphere. Let's place down a sphere. And keep that a little bit like a template here. And what I want to do, those are like way too big. So what I will do, I just will transform it like a little bit. And then we'll see. And what you can do, because what we will do, we will use the attach here, attached to geometry, and just place it near the surface. Of course, you could also work with groups, but I will place it just closely to the surface, and I think then we are really good to go. So it will automatically detach, it will attach to the collision geometry via distance. So that's pretty good. So this will be our inflate sphere. Okay, nice. So let's template that, and I will just place a few spheres here. I like one here. Then I would like another one, definitely here. That could be this. Okay. Then I could place another one here to make it interesting. So because that will then like inflate out. And you got a really cool collision geometry going on here because you got top and bottom, but like this little tunnel here is basically free and it could expand in there. Then another one here. Another one was here on the top. And let's go down, down. I think here one. And the other one maybe here. So it's not too empty. And I think that should work pretty nicely. So we got now a few different spheres here. And what we can do, we can all merge them. and then auto UV. Just go for an auto UV. Plop. And we've got UVs. Perfect. If we need them. You can't do it triplanar or procedural. Sometimes I think I'm currently on a design project, and there is procedural the way to go, but it of course fully depends like on the project. Okay, enough talk. Let's go. And after that, what I want to do, introduce like an attribute, and the attribute is called like pressure underscore mask. You can call it whatever you like. I just copy that, and then we will create a vector to vector 4, drive the noise with that, and then play with the noise here. Okay, then let's create a WOP, point WOP. Dive inside. I will make the points visible here, or our spheres, and an anti-aliased noise. Then we need a fit range, because we want to fit the noise from minus 0.5 to 0.5 as the source, and we want to fit it from 1 to, for example, 35. And then we will use our vector to vector 4, and the fourth vector will be the time. Wow, cool. And then what we can do, let's just visualize that. 0 and 1. Let's just visualize that. And I think that looks good. And I think what I also did on this one, okay, you can do it, you don't need to do it, you can ramp it, for example. If you want like a little bit more harsh inflation or deflation, you can ramp the noise and make it like a little bit more sharper, if you want that. Okay, back to 1 to 35, and then a bind export. And I just want to bind export that to an attribute called pressure mask, or you can basically call it whatever you like if you want. And then we can visualize that attribute, pressure mask, visualize that, and it's from 135. I hate also this new Houdini visualizer. I don't know why is it so bright? I don't know, I hate it. Oh. And then we've got here our little visualizer, which is looking good. Then after that, we'll build up our little vellum simulation. So we've got our vellum cloth. Then what we've got our attaching, we've got our pressure, and our solver. So that's basically it. Reset viewport. Thanks. Okay. So vellum configure balloon. Let's place that down, pipe it in here. And what I want to do on the stretch here, on the stiffness, what I want to do is to get like 1 and make it really high. For now, of course, you can change that if you want more wrinkles, etc. You can do that. Then the pressure. The pressure is also on my pretty high, so 6.1E10. 6E10. And then important, what we need to do, we need to output a group. And let's just call the group stretch. We will call that pressure group. And we will use that group internally on the vellum solver to activate or to import our attribute here. Set pressure mask. To import that and use it. Then we need vellum constraints. Vellum constraint. Oops. And we will set them to our lovely collision. And we will use attach to geometry. And then what I will do is to just get like the max distance here and play a little bit with the distance. So you can play around with that. But I think if every point got a few connections, that's perfect basically. You can also do it procedurally or with groups. And I think maybe I will later get in here another sphere in. Or let's just do that now because it feels a little bit empty up there. so let's get the little sphere up there, another little sphere friend. So they are not that alone. I think here would be cool. Yes. Maybe I will add one more later. Rule of odds. Okay. But I think that's fully fine. So we got our pressure, we got our pressure mask, we got our attached thing. And then what we need to do, we need to place down our vellum solver. Perfect. And yeah, we got basically our vellum solver done. Let's dive inside, and we need a vellum configure constraint properties, and we want to work on our pressure group, rest length, use vex expressions, and we need inputs. We need first context geometry. Let's see if I did that right also here. Yeah. Then we need to code that a little bit. So the rest scale equals, or let's just do a time equals. The rest scale, this is on our pressure. So this one here, which controls basically the inflation of the balloons. And what we want to get point attribute, and we will work on input 2, and then we will call that pressure underscore mask, and then it will be at ptnum, so at the point. And we'll close that, and that should work. So when we start now our little vellum solver, we should see them inflate. Yes. And deflate. And so on. So here now our little, you can see this one here deflates now a little bit. This one too. So the cool thing is what we now can do with our little pressure mask here, we can control that. So if we don't want that much inflation, we can, for example, go it from 1 to 15. Now let's play it back quickly. Now it's a little bit more subtle, so I think it will start pretty heavy in the beginning, of course, again. It's not that high. Just go. Few sub-steps. And then you can basically play around with several attributes, I might say. One looks also good. And what I will do for now, I think, could also try like low value. what you could do, go down here a little bit. And what I will do now, I will just like cache it out one time, and then we can see like a final result, and I will be back in a second. So, hello again, guys. So I simmed like a few frames. And what you of course need to do, what I failed so hard, not the rest length scale, of course. So just enable the rest length scale. So that's the right parameter. And I think something like that here works nice. But for this kind of scale, I think it would be cool to make them a little bit bigger. So what we could do, we can just get here to like 2 and pump that up. Let's see how. Okay, that's way more bigger. That's cool. And those are coming in, and the other one's going out a little bit. Yes, noise coming in here, for example. And the other ones are also growing like a little bit, or inflating a little bit. And I think something like that is really nice. I really like that frame where this one here comes out a little bit. I think that looks nice. Let's just cache those few frames here. And time shift. Select one that we like, and I like. This one here, frame 30. Delete channels, and we are good to go. So this will be our null. Oh, no, not a lobnet. Null out velum inflation. Perfect. Then we have this. After that, we can subdivide it. We can make our little attribute here. And then we are good to go for that part. So let's get a for each, because I want the bounding box for each geometry and not for all the geometry. And there's still the viewport bug. Go away, thanks. Let's just make the loop white here. And I want a VOP, point VOP. And before that, we can place a subdivide in here and go on open subdiv loop to get a little bit more geometry to work with. But it's with the bounding box, so the same thing we already did on our basically initial shape, vector to a float. And now you can decide, you can go from left to right, you can inverse that, top to bottom, or back and forth, normal color. But I will go from top to bottom, and I will bind that out. Bind export, and call it, I think I called it shading mask. Let's go mask, but let's check again. Mask shading, okay. Basically the same. Okay, cool. So we are ready with that. So this will be our final spheres. And then what I like to do in the end is to get a material and just do OC mat spheres. Oops. OC mat spheres. Perfect. Nice. So we've got that. We can even create a material for the spheres. Already did a few here. But yeah, standard Octane setup, special. What we can do, just create another material, mad spheres. Just stuff it here. And get a standard material. Let's just quick mark here and another quick mark here. So we are pretty fast in Houdini now with our little quick marks. You can set those with control 1, 2, 3, 4, 5, 6, and so on. And then jump with them with 1, 2, 3, for example. And the quick marks are view based. So if you set it like this, for example, on 3, you will also jump on this kind of view, and view 1 will be this, and view 2 will be this. So you can use them to get around in Houdini fairly quickly, which is sometimes pretty helpful, especially when you approach the deadline. Okay, then what I want to do is just to drag another one down here, material, and this will be OC Mad Core, so our main geometry basically. And let's call this main geo. And what we can do for the spheres, we can already hook them up. Spheres. And then the main geo, hook that up. Got already those two connected to our Octane shaders, which is pretty cool. Okay, then what we need here is our convex hull. We will do a mask with that kind of operation, and then a little bit of other stuff. Okay, let's place a convex hull. And I want to use that to get a mask on our main geo. So I can just show you it here quickly. So this will be our convex hull, and we will create a mask with that. And with that mask, we can then scatter points, for example. And we will scatter the hair onto them. And I really like that node. I think it's pretty fast and easy. Another step, what we need to do here is to VDB from polygons, and then we need to ray it, I think, one more time. And let's get a smooth convert, put that to polygons, and let's get a little bit more detail in here because, yeah. And I want to ray it because it's not, of course, the shrink wrap will be convex and not cave. Distance, and now we also get the other detail. Just copy that thing here. And we've got a fairly rough presentation of our geo. And we can use that mask from geometry. As our little helper. And I don't know, in this version, 20.5278, the mask from geometry on primitives is so lame. It's so slow, and I hate it. I don't like it. Okay, let's just get a mask going on here for our hair, and then we will use that for the hair and for our little guide here for our volume velocity advection. Okay, so now let's place a null here. This will be out geo for hair. Overcomplicated name. And then what I want to do is to place down a scatter node. And after the scatter node, copy the points. input, let's go in that, and then the normal points. So we've got that on our bolts, and then just a few, maybe 9, 7, I don't know. That should be fine. And let's just see. Okay, I did not use. We could use that, but for what I had in mind currently was we could use like the mask attribute here to control the scatter, but we really don't need that. Then a polygon, let's make it open. And what I want to do is to get here a little bit more points or divisions. So this is our thing here. What I want to do, just ray that down to our original collision geometry, minimum distance, and get a little bit of space between them and just move them up. Smooth it out. Up. Something like that. And I think that should work pretty nicely. Then we need to a volume velocity from curves. So volume velocity from curves. And this will be our surface and curves. And that should be fully fine. Of course, you can play with the resolution if you want to, but in this case, I think it's not necessary. But what you can do to visualize that, just get another scatter, pipe that in here, volume trail, velocity field and volume trail, and now you got your little thingies going on. But we want the overall more corrosive, not so fine surface flow. So we dial up the voxel size, so we will not increase the resolution, we will actually decrease it a little bit to get ourselves a little bit more overflow, which is pretty nice, I think. Let's mark that as a visualizer, so if we need to like visualize that, we have it here, and you can also see we can play a little bit around with points here with the global seed, and can get a good variety of advection. Okay, let's see at the time, easy. Now after that, what I want to do is to get a hair again, a guided vect, and then just 2 processes, and then we will continue. We need the 2 process nodes to like just shape the hair a little bit, the guided vect to advect it with our field, and the hair again to start our initial hair. So hair generate, and I usually color them in this brownish color. And let's just go density, skin attribute, and let's just mask. And I want more hair here. We can see that a little bit better. Let's make the dark. And you can see we will scatter on our mask attribute that we created. After that, we'll just place the guided vect. So guided vect. Type it in here, skin in here, velocity here. And you can already see we are advecting the hair with our volume velocity from curves, which I think looks pretty cool. Let's just color it in. Okay, after that, guide process set length and lift. Guide process set length. Here I just want to increase the length a little bit because I think it's not cool to have that short amount of hair, because I think you can get a really cool look if you just like randomize them a little bit and make them a little bit longer. And after that, a guide process, let's the lift, Let's lift it actually from the surface, but not, I think, that strong. So we can randomize that. I think that already looks pretty cool, not gonna lie. After the guide process, we will get the guide collide VDB. You don't necessarily need to do that, but if you're, for example, like on a commercial project and this full thing is then, for example, like animated or then I think it's pretty cool to get like non-connecting, not like any collision, internal collision or intersection with the geometry. Just get it here, 0.0125. Yeah, you can see, for example, here. It will then do its magic. And what you can do, you can even like offset the whole thing a little bit. That's also sometimes pretty helpful. So yeah, just use the sliders here a little bit, play around and see what will work for you. But I think that's already on a good way to go. So after that, again, we need another hair gen. We will then create basically our final hair and then a hair clump, and we could randomize it here again, which I did. I played with the length here again a little bit. But yeah, let's just use the hair gen again, so just copy it here. And what we now basically just use is our guides to then create our final hair. So let's just get the guides in here. And then a total amount, 250,000. Those are quite a lot. Those are not 250. Oh, those are, oh shit, that's the density. Total count. Let's just enable the total count. 250,000. Yeah, that's better. And then what I want to do is to just get the hair clump. Hair clump. Oops, wrong color. No. And then the skin and the skin VDB. Okay, those are big clumps. I think it looks cool. You can use that. I will use like a few more iterations here and the curling because I love the curling. I think it looks like, oh my god, that looks crazy. Because I think it looks like really, really cool if you use it like a little bit. And then fractal clump, blend clump size. I usually dialed it down a little bit so the clumps are like a little bit smaller. And then what I also do is like blending in it a little bit, random seed, and then crossover rate. Let's go 0.25. So they cross over like a little bit, a tiny little bit, which I think is pretty cool to do, to just add a little bit of imperfection. Another thing what I find pretty nice to do is, for example, if you copy the whole thing here and then, for example, here, let's go for 15,000. So not a lot, but what we could do on those hair is to just get another process here. And yeah, just make them a little bit longer. And curl them a little bit. And in the end, merge those two together. So what you then have is basically one layer of like a little bit longer ones and another layer with those ones here that are like a little bit more imperfect and stand out like a little bit, to just add some secondary detail, which I think is pretty cool to do. Cool. And after that, we will merge it all together. And we will place a group. Let's call that like that. grp_split. Oops, I created it and deleted it. And then what I want to do, that looks already cool. I want to split the geometry in the final step. And then out. Let's call this out main. And this will be our out hair. And for the out hair, what I want to do is to just get another merge in here. So create a new geometry container and get the hair out here. And then get the group here. And just in section. And then that should work right. Nice. Okay. Then we've got here our hair. And then we can do rotate it. And I already placed here like a little camera. Get a nice view here. And what I also did is create like a little background, so just a backdrop grid. Let's expand that a little bit. And let's make a new light. Another thing what we of course need to do for render for Octane, go to the Fur tab. If you don't have that, go to Shelf tool and then add object parameters while you are selecting the geometry container. Click on Fur and then render as curve/fur objects. And then the tightness, I just imported that. So we can use that for shading, for example, which I think is pretty cool to use. And yeah, basically you can use here masks if you want, but I will do it pretty simple. And another one for hair. Okay. 1, 2, 3. Let's go for the hair. And hair ones. Then we've got that. And I think let's go for camera 1. And create one Octane light. Octane universal light. Octane light 001. And this will be maybe like the main light. And let's look through that light side here. Camera should be set. It was like my first default created camera. And it looks something like this. We need more light. So let's go in here. But primitive, first of all, let's make that larger. Color tint white. And we need to focus the camera. Cool. After that, let's zoom out a little bit. Not like that. Here. Let's zoom out a little bit. Refocus. And what I want to do, maybe even rotate the whole thing. Oh wait, I'm currently rotating like everything. Here. Just rotate this piece. Because I think there are so many like interesting angles. I think that's pretty cool here. I like that one. Let's just use that one. And then I want to make my octane light here a little bit larger to get it a little bit softer. Okay, then I want another one. And this will be the side light. Let's just disable the octane renderer. And I want to place my side light on the other side. But let's go for a little bit down here. And what I want to do, I want to minimize the power a little bit on that one. So maybe half of the power. Okay, that looks quite good. And then what I want to do is another light, and this will be just this will be the background light to illuminate our little background. It's just a simple background with a rough color on it. So we are now here. Let's make that from the top. Something like that. I think that will work a little bit better. And what I want to do is to zoom out even a little bit more. I want to isolate it like a little bit so it like flows in like nothingness. And I think we need. Okay, I think that looks nice. Okay. Now what we can do, we connected already our hair. Let's go in here. And what I want to do is to get our tightness attribute, this one here. Point vertex color, float vertex color, tightness, and then gradient. Pipe that into the base color. Let's see, that should work. Yes, perfect. And then you can, for example, change the color here, which is, I think, pretty cool. So, let's go for white to red. Oh, that looks quite cool. But I want to make it like a little bit more orangey. Just a little bit, and then reverse it. Or maybe let's just make it red. And then a little bit metallic. And increase the specular roughness a little. Okay, then the main geometry. I think there are a lot of like nice things you could do with it. I think a metallic material would also help, but maybe Let's try out a glass material. Glass materials, looks okayish, but I think what would work the best, like maybe like a subsurface. So let's go for subsurface weight, radius, color. And the roughness, I think that's quite cool. And then for our, let's use a noise here, or like a matrix. Procedurals. What do we have here? Color squares, fractals, or mosaic. Let's just use a triplanar and then play around. So here, and then we need a scale, and then we need a triplanar projection. And for example, procedurals. Yeah, let's see. There are a lot of nice things to choose. What is like the more mosaic? Let's just put that in here. Okay, I can already see it. Projection. Scale. Just scale it down a little bit. Oh, that's cool. What? Okay, fuck it. It's not like perfect. Oh wait, we don't need triplanar. We can also use our mesh UV. That in here, pipe that into. Yeah, but okay, that looks way worse. Let's just blend it. Let's just blend it. Oh, that's trippy. That's trippy. Okay, ring spacing. I never used that node. Time. Oh, you could animate it? What? Okay, let's just let it like this because I think that looks kind of like fabric. And then I want that to pipe that into a multiplied texture and that into bump. Yes. And then a metallic surface. Or glass. I think glass would be also cool, but let's just try. That's too much. And then what we can do, because we got our sphere, we got our, the thing is how I called it. It's just shading mask. Okay, let's import our shading mask here. Shading mask, where is it? Here. And what I want to do, load, gradient, here, type that in here. And let's just refresh our, and we've got our shading mask. So we can play around here also with shaders, which is pretty nice. And yeah, so now you got your fully basically setup to like play around and make some nice renders or animation, etc. And yeah, so play around with the oval shape, lighting, and so on. And I hope to see you in the next one. So take care and have a great weekend.